Good evening, everyone. Good evening, friends. So, welcome back to our day 16 of Python for AI session. So, we have successfully completed 15 days, right? So, we'll quickly recap what we have covered in the previous session. Then, we'll just continue with the rest of the topics. So, in the last class, we have started with operators, okay, in which we have covered all the four types along with fifth and sixth type. Okay, so let us quickly recap all of these concepts. So operators are nothing but symbols which help us to perform certain operations. Then using these operators, okay, so if it is going to connect two or more objects, then it is called as an expression. In Python, we have 7 types of operators. They are arithmetic, assignment, relational, logical, membership, identity, and bitwise. So arithmetic operators, they help us to. What is the purpose of using arithmetic operators? They help us to perform basic arithmetic calculations. Arithmetic operations can be performed using arithmetic operators. We have addition, subtraction, multiplication, division, floor division, then followed by power, and we also have modulus. Yes, we have discussed all these operators were being discussed, guys, in the last sessions. Then next to arithmetic operators, we have assignment operator in which we have only one operator. It is equals to. So what is the purpose of assignment operator? Assignment operator helps us to assign the right hand side value to left hand side variable or left hand side object, whatever it might be. Then relational operators. What are the different relational operators that we have in Python? Greater than, less than, is equals to, not is equals to, greater than is equals to, less than is equals to. Right? Yes. I want everyone to interact. Okay. So the moment that I'm asking a question, you have to keep your answers in the live chat. So what is the purpose of relational operators? What is the purpose of relational operators? They help us to compare the values, right? So two values can be compared using relational operators. Next to relational operators, we have logical operators. Good. Then what are the different logical operators that we have in Python? And, or, not. What is the purpose of logical operators? Logical operators help us to combine two or more relational expressions. If there are two or more than two relational expressions, so that can be combined using logical operators. I can use AND or operator. When does an AND operator return true? Before that, the output of relational operators will always be either true or false. In the same way, a logical operators will return either true or false. Apart from true or false, can you have the third value as output? Can you have any other value as an output? No. No. Okay. Then, in the recent session, we started understanding membership operators. So what are the different membership operators we have in Python? We have in, not in. In and not in are the membership operators that we have in Python. What is the purpose of membership operators? What is the purpose of using membership operators in Python? Why should we use in and not in? They help us to check or verify whether a value is present or the existence of a value in an iterable object. Okay, so the existence of a value can be verified, can be checked in an iterable object using membership operators. What will be the output of membership operator? Again, it will be seen true, false. It will be same. When does an in operator return true? When the value is present inside. If the value is existing inside an iterable object, in operator returns true. If the value is not present inside the iterable object, it returns false. Okay, the vice versa of in, you'll get it as not in, guys. Not in works quite opposite to in. Making sense? Then we also discussed identity operators. What are the different identity operators that we have in Python? We have is not, is and is not. So tell me, what is the purpose of using identity operators? They help us to compare the memory address. So within the memory, whenever we are going to store objects, okay, so whenever we are going to store the variables, the values within the objects, so the address of these objects can be checked using identity operators, whether both the objects have same address or a different address. Okay, so in short, they help us to compare memory address location. Then the output of identity operators will be again either true or false. Can we have anything else apart from true and false? No. No. So we also worked out on is and is not operators by taking each and every different value, different type value. Okay. So all the 14 types we have tried on which we used identity operators. Right. So can you tell me the special cases? What are the special cases we have where the memory address of the objects will be same? In which cases we got true when we are using is operator? Come on guys, respond. What are the special cases where we got, I mean, for the objects, the address is same. In which case it is? Good, good. So these are the special cases under identity operators where the objects get stored at the same location. Okay, so the objects will have the same location. What are they? If you are trying to store either true or false, that means bool type values. Okay, if not, if you are trying to store any small int value ranging from -5 to 256, if the range of the numbers that you are trying to store, if it is -5 to 256, Python uses the concept of memory optimization. So within the memory, both the objects will have the same address. The address will be same. Even when it comes to none type, as we can have only one none, it is a singleton object, right? So these singleton values can be shared. The objects will have the same address in the memory. And even for str type, if it is small strings, only in this case, we can have the objects with same address, same location. So these are the special cases and we have discussed, right? I hope hands-on is also done. Now let us go to the next operators. It is bitwise operators and very important. It is very important. So I want everyone to focus. So let's just continue. The next operators that we are going to understand are bitwise operators. So let us understand what is the purpose of using bitwise operators. In Python, the bitwise operators help us to perform bitwise calculations. They help us to perform bitwise calculations on integer data, but not on float data. Okay, so they help us to perform calculations, bitwise calculations only on which type of data? Int, not on float. No. The reason is when you use float, because of the number of decimal places getting changed internally, they don't allow to work on float type values. Only int type data is accepted and the bitwise calculations performs. It performs bitwise calculations. Isn't it? Yes. What happens when we use bitwise operators? When we use bitwise operators internally, the int type data that we use gets converted to binary format. What do you mean by binary format, friends? Int type data, this is getting converted to binary format. What do you understand by the word binary? Binary format. 0 and 1, right? Zeros and ones. So whatever the int type value that you are taking, okay, so this int type data gets converted to binary format, that means zeros and ones, and performs the bitwise calculations bit by bit. It performs the calculation, and that is the reason they are named as bitwise operators. Why they are named as bitwise operators? Because they perform bitwise calculation, and even as part of the output, this binary format will be converted back to decimal format, same back to the int type data, and it gives the output, right? So this is the process, and in total we have 6 bitwise operators. What are they? Bitwise left shift operator, bitwise right shift operator, bitwise OR operator, bitwise AND operator, bitwise complement operator, and finally bitwise XOR operator. XOR operator. And for each and every bitwise operator, we have the notations. So it is not less than, double. Okay, this is less than symbol. And if you are using double less than symbol, two, twice, that becomes a bitwise left shift operator. This is bitwise right shift operator. Okay, but here comes the question. I think we also use these symbols somewhere else. Where did we use these symbols? Any idea? Vertical pipe, ampersand, then cap. Did we use these symbols anywhere so far? Come on, guys. Yes, we have used these symbols as part of. No, no. Where did we use? Set category data types. Perfect. Wonderful. Under set category data types, did we discuss set type? Yes, set data type was being discussed, in which we have union, intersection, difference, symmetric difference. Are they saying? Yes. Okay, I'll talk about this. No worries. How PVM is going to identify whether it is a union symbol, intersection symbol, or bitwise OR operator symbol, or bitwise AND operator symbol. We'll understand. No issues. Okay. Right. So let us start with bitwise left shift operator. I hope it's very clear on the purpose of using bitwise operators. The purpose of using bitwise operator is they perform bitwise calculations and they don't work on float type data. They only work on int type data. And internally, this int type data gets converted to binary format, zeros and ones. Then the bit by bit calculations happen. And again, this bit, the binary format, the output that you get in the binary format will be converted back to decimal format, decimal number system. Okay, and that will be returned as output. So this is what happens internally. Okay, so let us also understand, that's not an issue. Let us understand by understanding all the 6 types of bitwise operators one by one. But pay attention, friends. Very important. Bitwise operators are very important. Let us start with bitwise left shift operator. What exactly is this bitwise left shift operator? You see here, bitwise operator, in which the first one is bitwise left shift operator. Before that, I'll go back. Yes. Probably here we have the explanation. What does bitwise left shift operator does? Okay. So bitwise left shift operator, we represent using double less than symbol. Okay. So less than used double time is bitwise left shift operator, and the functionality of bitwise left shift operator is it shifts the specified number of bits towards left side. Towards left side, the number of bits gets shifted, and because of this it is going to fill number of zeros on right side. Probably not understood, right? I'll go back. Here we'll understand here. I'm going to take an example. So I'm trying to use bitwise left shift operator, okay, where I'm using 10. Okay, I'm trying to use 10, which is an int type data. Is it int type data or float type data? It's an int type data. Accepted. I can perform bitwise operator. I can use bitwise operators on it. Yes. So internally, this 10 gets converted to which format? Zeros and ones. Zeros and ones. So how 10 gets converted to zeros and ones? Just divide by 2. I hope all of you have attended the number systems concept. As part of number system sessions, we have understood how the conversions to be done from decimal number system to binary number system. Then from binary number system back to decimal number systems. The conversions, very important. So friends, if you are joining for the first time, just subscribe our channel so that all the important notifications you'll be getting, and soon we are going to plan upcoming sessions as well, right? So just go through the session where we have covered the conversions, right? So let me take 10, okay, where I have to divide 10 by 2. Why 2? Because a decimal number system, a value which is present in decimal number system is getting converted to binary number system. In binary number system, how many numbers you will have? Just only 2. So that is the reason we divide by 2. So it will be 2 5s are 10. The remainder is 0. Again, 2 2s are 4. The remainder is 1. 2 1s are 2. The remainder is 0. Now go in this fashion. You go in this fashion, it is 1 0 1 0. So 10, which is in decimal number system, it got converted to binary number system, which is represented as 1 0 1 0. That is the fact, that is the reason I'm taking a 16-bit computer, which stores 10 in this fashion. You take a 16-bit computer, okay, in which it has 4 boxes, right? So this 10 internally converted to binary number system, and that is what it is going to store, where the rest of the values will be 0. Yes. Now, what operator I am going to use? Left shift operator. What does left shift operator does? Left shift operator, moves the bits. It is going to move the number of bits to the specified number of bits towards left side. If I move these values, these are nothing but bits, right? If I'm going to move these values by how many positions? 3 positions. So if I move in this direction towards left side, the first 3 zeros will be coming out of this box. Am I right? Yes. So obviously, the position of these values will change. So this will be at this position. This comes next to it. Then so on. Right. So if I go in this fashion, where will I have the 1? I'll have it here. The next 0, I'll have it here. The next 1 here. And the 0 at here. So that is what you see in this output. Yes, this is what happened. And what you'll have next to 0? You'll have 3 empty places. You'll have 3 empty places. Why? All the values got shifted to the left side. The bits got shifted to the left side, and there will be 3 empty places within this box. This will be by default taking the value of 0. Okay, so when you try to convert this binary number back to the decimal number, you have to just use this formula. Enough. Okay, you can directly use this formula in the sense, whatever the data that you are trying to use, here we are using 10, right? Then how many number of bits we are trying to change? I want to change, I'm using left shift operator, and I want to move this 10 to 3 bits towards the left side. And I can directly use this formula. Given data multiplied by 2 power number of bits. So 10 multiplied by 2 power 3. So which will be 10 into 8, which will be 80. The output will be 80. Either you do in this way or this way, both are same. This is the shortcut. Okay, so this is the elaborated way of understanding bitwise left shift operator, guys. Okay, but here we have a shortcut. It is whatever the data that you are trying to use, okay, on which we are trying to use this left shift operator, specifying the number of bits towards how many spaces, how many bits you want to move it. I just want to move it to 3 bits. So it will be 2 power 3. So the answer is 80. 80. Okay, so the detailed explanation, and this is the shortcut. You can use any one of this. That's not an issue. But I hope bitwise left shift operator is clear. Okay, so the elaborated way, depending on the number of bit computer, it is storing the data. Okay, converting the int type decimal number system to binary number system, and it gets stored. Then, depending on the number of bits to which we are supposed to move towards the left shift operator, you know, the number of places gets moved. Accordingly, it is getting replaced with the zeros at the end. This is what happens. Even if you try to take this number and convert back this binary system, binary number to decimal number back, you'll get 80. 80. Right? So I'll go back. If it is clear, let me do it on a example. What are we doing? I'm just taking a int type value, it is 10, and storing it inside A. I'm storing it inside A. Just have a look. It's done. Now, what I'm trying to do, I'm using bitwise left shift operator. Okay, and I want to shift by how many bits? 3 bits. The same example, guys. It is 3 bits. So what happens? 10 gets shifted to, initially it gets converted to binary number system, which is 1010. Okay, so this gets shifted to 3 bits. So when it moves towards the left side, at the end you'll have, it will be by default replacing the values with 0. You can simply use the shortcut. Given data multiplied by 2 power number of bits. So the output should be 80. The output should be 80, where it gets stored in RES, because that is a variable, that is the object that I'm using. So it gets stored in RES. Done. I'm printing it. I hope it's clear. Can you work out on the next example? 2869, where I want to, perform left shift operator, bitwise left shift operator on 50 by how many bits? 2 bits. Just give a try. What will be the output for line number 2869? What will be the output? I want everyone to respond. Simple. Just use the shortcut, friends. When you are using bitwise left shift operator, yes, I'm using bitwise left shift operator. What is the shortcut? Data multiplied by 2 power number of bits. So this is nothing but 50 multiplied by 2 power 2. How many bits? It is 2. So 2 power 2, 50 multiplied by 4. It's nothing but 200. This is the easiest way of, getting the output. If not, you can also do it in the first approach, whatever we have discussed. So what happens is 50 gets converted to binary number system initially, binary format. So 2, 25, 0, 2, then 12, 1. 2 12s are 24, the remainder is 1. 2 6 are 12, the remainder is 0. 2 3s are 6, the remainder is 0. Then 2 1s are 2, the remainder is 1. So this is the binary format of numbers 50. So it is 1 1 0 0 1 0. 1 0. Then this number has to be shifted to how many bits? 2 places. So that means, this will move towards the left side. When you move towards the left side, what happens? It is going to create 2 empty places at the last. When you move this number towards the left side, at the last you will have 2 places which will be occupied by 0. Now this binary number which is present in the binary system will be again converted back to the decimal number system. So the output, when you try to do the conversion, you'll get 200. So which method you want to choose, it's up to you. Obviously, shortcut is what all of us prefer. Yes. Yes, this is what we do. Okay, even for competitive exams, this is the best trick that we can use. Okay, for performing bitwise left shift operator, friends. Very important. Yes. So you take this number and we have covered as part of conversions. A specific session was done on conversions. How a binary number system value which is present in binary number system should be converted to decimal number system. We have discussed. We use 2 power n formula. Probably, I hope everyone remember, right? So just use it. Again, you'll get 200 only. Whatever might be your method, the output will be seen. The output will be seen. Right? Now, let me execute line number 2869. Will the output be 200? Yes, it is 200. Is it clear? Simple, right? Yes, it is simple. Now, let me go and work out on the next operator. Bitwise right shift operator. What is left shift operator doing? Left shift operator is actually, it is shifting the number of bits towards left hand side, left side. But right shift operator, the functionality of the right shift operator is it shifts the number of specified bits towards right side. I mean this side. Whatever the bits that we have gets shifted towards right side. Then wherever we have the spaces gets replaced with zeros. So obviously when you move towards the bits gets moved towards the right side, you'll have the gaps at the left side. So these get replaced with 0. 0. And what is the symbol? It is greater than. Not single one, it is double. Double greater than symbol, it is representing bitwise right shift operator. For better understanding, we have an explanation for right shift operators as well. The same. Okay, if I take 10 and I'm representing in binary number system, so We know that computers understand only binary number systems, right? So it is zeros and ones. Zeros and ones. So 10 getting converted to binary number system, and if I am using a 16-bit computer, it stores 10 in this fashion. In this fashion. Okay, so what operator are we using? Right shift operator. A right shift operator has to shift the bits towards which side? Right side. So if I shift the bits, here we have the bits, right? Zeros and ones. If I'm going to shift these bits towards right side, towards which side we'll have spaces? The gaps we'll have at the left side. But how many places? It is 3. You have to observe. Okay, so that means towards 3 places, I have to move towards right side. So if I move towards the right side, 0 will move out, 1 will come out, and the next 0 will also come out. All these 3 values will come out of this, representation. We'll just have 1 at the last. And as 3 values came out of this particular representation, we'll have 3 spaces created at the initial stage, and these will be by default 0. The values will occupied with 0. Now, this is in the format of binary system. You convert back to decimal number system. So how we can convert? 2 power n, right? So at which position we have? We have it at 0th position multiplied by the value 1 multiplied by 2 power 0. So it will be 1. So the output of this particular question is 1. If not, we have a shortcut, friends. Again, even for bitwise right shift operator, we have a shortcut. Okay, like how we are using a shortcut for left shift operator, given data multiplied by 2 power number of bits. In the same way, there is a shortcut for right shift operator. Instead of multiplying, we divide. Given data divided by 2 power number of bits will give me the result. But it is not actually the division. We use floor division. It is performing floor division. So we get again a base value only. So either you do in approach 1 or approach 2, your output should match. Your output will be same. I hope it's clear. If you understood the process, let us go and work out on examples. You guys have to respond now. What will be the output for line number 2877? 2877. So friends, what will be the output for 2877? The answer will be 1. The same example, whatever we have discussed so far, whatever we have discussed as part of the explanation, the same. Taking 10 and we are using right shift operator, bitwise right shift operator, and we want to shift 10, the number of bits with 3 places. So the output will be 1. Can you give me the answer for line number 2878, the next line? Yes. Even we can also use shortcut. What is a shortcut? See, data divided by 2 power number of bits. It is 3. 10 divided by 8. But it is not actually division, floor division. When you do division, you'll get the coefficient, right? So it will be 1 point, 2, so on. But it is actually floor division. The base value only has to be written. So the output will be 1. So the answer for line number 2877 will be 1. Then in the same way for the next line 2878. Will it be 2? Let me check. 10 divided by 2 power 2. 10 divided by 4. So obviously it will be 2.5. So the base value has to be retained since it is floor division. The output will be 2. Is it clear? So just memorize the shortcuts. At least if you are memorizing the shortcuts, you can answer any kind of question that can be asked under bitwise left shift as well as bitwise right shift operators. Clear? Is it clear, guys? Can I go to the next operator? Yes. Perfect. Then coming to the next operator, we have bitwise OR operator. Bitwise OR operator. And we represent bitwise OR operator using vertical pipe. Where do we have this vertical pipe on the keyboard is if you are using Windows keyboard, Windows machine on the keyboard, there is a button we have backspace. So down to backspace, you'll have this, there is a key which have this symbol. This is called vertical pipe. Okay. Now, I'm going to use bitwise OR operator. But before that, we have to understand the functionality of the bitwise OR operator. Right? So we can understand the functionality of the bitwise OR operator using this truth table. Okay, if the value for P, if there are two different values, two different int values, and internally we are going to convert them to binary format. Yes, if the bit values for these numbers are 0, 1, and if you are using bitwise OR operator, the output will be 1. If the bit values are 0 and 1, the output will be 1. If it is 1, 0, again the output will be 1 only. What if both the bits are 1? The bit output will be again 1. Only if the bits, both of them are 0, the output for bitwise OR operator will be 0. So this is similar to what operator? Logical, or where we have true false. But we are working on bitwise OR operators, right? Where bitwise operators, they work on bits. Bitwise calculations will be done. So just replace true and false with 0 and 1. Okay, so true will be 1 and false will be 0. Just replace them. You can easily memorize the truth table of bitwise OR operator. Simple. Okay, so let us work out an example. Then you can also try it on other questions. So what are we doing? I'm going to store, an int type value 4 in A and 5 in B. Okay, and on these two int type values 4 and 5, I'm going to apply bitwise OR operator. So internally 4 gets converted to binary format. 5 gets converted to binary format. For 4, the binary format is given as 1000000. Then 5, it is 101. Now, if I use bitwise OR operator between 4 and 5, just can you give the output? If the bits are 0 and 1, what will be the output? It will be 1. What if both the bits are 0? The output will be 0. What if both the bits are 1? The output will be 1 again. Okay, so in this way, I got the output for 4 bitwise OR operator 5. If I am trying to use bitwise OR operator between 4 and 5, I got the output as 101. But it will not return me the same value as it is. This will be converted back to decimal number system, decimal format, which is 5, and this will be returned as output. Clear? So this is the process for bitwise OR operator. For better understanding, let me execute. I'm taking 4, storing in A. Done. I'm taking 5 and I'm assigning to B. Done. Then on these two objects, I'm performing bitwise OR operator. Where are the results getting stored? The results get stored in C. So let me execute. What value do we see in C? It is again 5. That is what we got as an output. Is that the output? Yes. So let me also print C to the console. It is 5 again. In simple, a bitwise OR operator will return the output as 0 only if both the bit values are 0. In rest of all the cases, the output of bitwise operator will be 1. That's it. Is it clear? Will you work out for the next line? So I want you guys to, give the output for the next line. 2896. What will be the output for 2896? Do the conversions and let me know the answer. Give me the answer. Will it be 15 or 9? What will be the answer? No, no, no. I want it in decimal format, not in binary format. Decimal format, guys. No, no, no. Not accepted. For line number 2896, I want output in decimal format. So convert this 1111 It will be 15. Good. So I'm trying to use bitwise OR operator between two values 10 and 15. Okay. So internally what happens is this 10 gets converted to binary format and 15 will also get converted to binary format. Then the bitwise OR operation happens where you get 1111. Okay. And this 1111 will again be converted back to decimal format. The output will be 15. Good, good. That's it, guys. When you respond, you'll be learning. Right? When you interact, you'll learn something. Right? Yes. Keep it up. In the same way, I want you guys to work out on the next example. 3 bitwise operator or then 4. So on 3 and 4, we are using bitwise OR operator. What will be the output? Keep going, keep going. How it will be 7? Are you guys sure? Let me also check. So 3 initially has to be converted back to what? It has to be converted to binary format. So 2 ones are 2. The output is, the remainder is 1. So 3 is represented with 1, 1. Then coming to 4. Okay. So When you take 2 2s are 4, right? What is the remainder? 0. Again, divided by 2. 2 1s are 2. The remainder 0. So, what do you have? You have 100, right? So, just perform the bitwise operation. Here you don't have anything, which means 0 again towards the left side. Okay, so the empty place takes 0 by default. Now perform the OR operation, bitwise OR operation. If I just have one, at least one in each and every case, the output will be 1. So now convert back this binary format to decimal format where we use 2 power n. So the output will be 1 multiplied by 2 power 0 plus 1 multiplied by 2 power 1 plus 1 multiplied by 2 power 2. So this will be 1, this will be 2, this will be 4. So the output will be 7. That's it. See, if you understand the logic, if you understand the concept, any kind of question can be answered. Okay. If you don't understand, it will be something is going on, but we are trying to understand. That doesn't work, right? But the question raises now. What does the question is? Even for union operation under set type, set data type, we use the same symbol. Did we use the same symbol? Vertical pipe? Yes. Then how does PVM, Python virtual machine, understands whether this vertical pipe is a symbol for bitwise OR operator or union function under set type is depending on the values. Okay, depending on the values that you try to use. Okay, in case of sets, see here I am trying to use set objects, and if we use the same vertical pipe, it performs union. But if you are just using int type values, it performs bitwise OR operation. So that is how PVM understands. Depending on the values, the objects that you are trying to use here. In each and every case, it changes, guys. Okay. I hope it's clear. Now, let us quickly recap the union case as well, because as we are using the vertical pipe, the symbol vertical pipe, let us quickly recap. What are we doing in line number 2900? We are creating a set object with how many elements? 3 elements, 3 values. All the elements, are they organized? What are the properties of set type? Can we perform indexing and slicing operations? No. No. Right? So I'm just creating a set object of size 3 S1, and these are the values 10, 20, 30. Set type does not allow insertion order. I hope all of you are, all of you remember the properties of set. No duplicates. Good. Then I'm also using, I'm trying to create one more object, set object with 4 elements. Then what does union function does? What does union function does? A union function will return all the elements from both the objects. So what will be the output for line number 2902? We cannot perform indexing and slicing because set does not allow us to. It does not follow the insertion order. Good. So what will be the output? A union function will return all the elements from both the objects. Okay, but they has to be unique, not duplicate. Perfect. 10, 20, 30, 40 and 50 in any order. Let me execute and print. See. It can be in any order, friends. Perfect, perfect. Then what are we doing in the next line? 2905. I'm using the same union function. Okay. Instead of union function, I'm using vertical pipe which performs the same union. Okay. This vertical pipe represents union only. Okay. Why? Because I am working on two set objects. So this is going to return us all the unique elements from both the objects S1 and S2. So let me print S4. Done. S3 and S4 will have the same elements. I'm using a function and just replacing the function with a symbol. Both are seen. That's the only difference. Then in the next example, we are trying to use str type values inside a set object. Okay, inside the curly braces. So it is going to form a set object of size 2 and even S2 is also a set object of size 2. Done. So what will be the output for line number 2910? Where we are using union vertical pipe which represents union operation only, union function. It will be apple, mango and kiwi but in any order. Yes. It can be in any order, friends. Right? So we have also recapped the concepts of union under set type. Set data type, we have revised the concepts of union. Now let us go to the next operator under bitwise. It is AND operator. It is bitwise AND operator. So what does the functionality of the bitwise AND operator say is, we have it in the truth table. Bitwise AND operator, it is denoted with ampersand. Okay, and we have the truth table here. If you observe, is this similar to logical AND? Yes. Under logical operator, we have one of the operator as AND, where the values will be true, false. But just replace the values within the truth table. For true, you just keep it as 1. And for false, you replace it with 0. You'll get the truth table for bitwise AND operator. If the bit value is 0 in one case, and if the bit value is 1 in the other case, the output will be 0. Even in rest of the two cases also, it is 0. When we can get the output as 1, only if both the bits are 1. In rest of other cases, it will be 0. So that is the difference, friends. It is same. Similar to logical AND, where we have true and false as the values. Clear? Yes. Now, I want you guys to answer for, line number 2926, where I am performing bitwise AND operation. I am storing 4 in A and assigning 5 in B. Okay. Now, Between 4 and 5, I'm using bitwise AND operator. So what will be the output? Storing 4 in A and 5 in B. Done. Done. So what will be the output for line number 2926? These decimal numbers, the numbers that we have, they are present in decimal number system. They'll be converted to binary format, zeros and ones. Then bitwise calculations will be done. Bitwise operations will be done. Okay. Again, once after getting the binary number as output, that will be converted back to decimal format. The same process. So what will be the output? What will be the output? It will be 4. Let me print it. How come 4? How come 4? How do we represent 4 in binary format? 100, right? Let me keep it here. So this is represented as 100 and 5 is represented as 101. Now you do bitwise calculations. So at which point we'll get 1? If both the bits are 1, only at that particular case, the output will be 1 when we use bitwise AND operator. So that means only in this case we'll get 1 as output. In rest of the two cases where we have the bits as 00 and 01, the output will be 0 only. So in total the output will be 100, which is nothing but 4. Simple. Now, can you also guys try the next line 2928? 2928. 5 bitwise operator 15. 5 and 15. What will be the output? The output will be 5. Again, the same calculations, friends. For the next line, 2929, 4 and 3. 4 bitwise AND operator 3. 4 bitwise AND operator 3. The output will be 0. Why 0? Because none of the bits matches in this case. Just do the conversions. It is very simple. There is no complex maths involved. Right? Very simple. Now, what I'm doing is, let us also quickly recap the intersection topic that we have discussed as part of, sets. Under sets, we have discussed intersection. Right? So if you see here, I'm using the same symbol ampersand, which we also use for intersection function. Okay, so PVM is capable of identifying, whether it has to perform intersection or bitwise AND operator. It depends on the values, the objects that we are trying to use along with the symbol. So what are we doing in line number 2932? I'm trying to store 3 different values. 10, 20 and 30 in curly braces. So it is going to create a set object. Done. S1. Then In the next line 2933, we are going to create one more set object S2 with three more values 20, 40, 50. What does intersection function does? Intersection function will just return the common elements between the objects. Between two set objects, the common values only will be written. So when I use S1 dot intersection of S2, what will be the output? What is the common value? I see the common value is 20. So the output should be 20, which gets stored in S3. But this 20 will be inside flower braces. It is a set object where the size of S3 is 1. So let me print S3 to the console. Done. It is not just normal, number 20. It will be inside flower braces, guys. No, in competitive exams, they can make the question tricky. As part of answers, they'll just give a 20, then flower braces in which we have 20. So the answer will be 20 inside the flower braces, not the number 20. No. Okay. Focus. Now, what am I doing? I'm trying to use the same set objects, S1, S2, but instead of using intersection, I'm just replacing with AND. I'm replacing with ampersand function, which also does the same intersection only. The common values, the common elements between S1 and S2 will be returned. So I get the same output. I'll get the same output. Clear? Right. Now let us understand the next operators. Okay. Within the bitwise operator, we have the next type. It is bitwise complement operator. What is this bitwise complement operator? Is this operator, the complement operator is represented with tilde, a negation. A negation symbol is used to represent complement bitwise operator, and this is going to return us the complement of a given value. Whatever the value that we pass, for this value, the complement value will be returned. Okay, so we have a formula for it. When you are trying to take any value, the complement of the value will be given as minus of n plus 1. Minus of n plus 1. Assume that I want to get complement of 5. So wherever I have n, I have to substitute, 5 in place of n. So it will be minus of 5 plus 1. It is nothing but minus 6. It will be minus 6. So for 5, the complement value that we got is minus 6. That we can achieve using complement bitwise operator, bitwise complement operator, which is represented with negation symbol, the tilde. Okay, so here we have a few examples and you guys have to respond, right? So I want to get the complement of 10. What will be the output for 10? Just substitute 10 in place of n and give me the output for line number 2948. Print of, tilde a. What value do we have in a? It is 10. So the output will be minus of 10 plus 1, minus 11. Did we get minus 11? Good. Keep going. Then in the next example, I want to get the complement of 100. I want to get the complement of 100. So I'm using bitwise complement operator tilde on the value 100. So just replace 100 in place of n. Wherever we have n, replace it with 100. So what will be the output? 100 plus 1 will be 101. So minus 101 will be stored in res. When we say print of res, it will print minus 101. Keep going, don't stop. Everyone has to respond. Then I want to get the complement operator to be applied on minus 108. Minus 108. So what will be the output, friends? Will it be minus 109? What will be the output for line number 2955? Simple calculations, additions. 108. It is not just 108, it is minus 108. So minus of minus 108 plus 1. It will be minus 107. Minus of minus 107 will be 107. Let me print. Here I got 107 as the output. Clear? So any kind of question, whatever might be the value, you can get the complement of the given value when we use, the bitwise complement operator, which is represented with tilde. And the formula is tilde of n is minus of n plus 1. Just remember these formulas. If you remember the shortcut formulas, you can solve any kind of question. Any kind of question can be solved. Right? Good. Now, let me go to the next operator. It is Bitwise XOR operator. Bitwise XOR operator. So even for Bitwise XOR operator, we have a truth table and let us understand it. We represent Bitwise XOR operator using cap. Okay, right. So let us understand the functionality of XOR. If you have the bits in the fashion of 0, 1, okay, if the bit is 0 in one keys and if the other binary number, if the bit is 1, the output will be 1. The output will be 1. What if the bits are 1 and 0? Again, the output will be 1. But if we have the same bit values 0, 0, 1, 1, in both the cases, if the bit values are same, then the output will be 0. Only in that case, the output will be 0. Making sense? Yes. Now let us use bitwise XOR operator exclusively OR operator on an example. So let me take A is equals to 4. We represent A is equals to 4. Now 4 will be represented in the binary format in 1, 0, 0. If I take in the same way 5 in the format of binary system, it will be 1, 0, 1. Now, what operator are we using between these values? Bitwise XOR, exclusively OR operator is what we are using. So what will be the output? What will be the output for, Line number 2971. Or 2972, whatever it might be. What will be the output? I don't want it in bit binary format. I want the output in decimal format. Convert it. 001 will be the output. So this, when we convert binary format to decimal format, the output will be 1. How come 1? 1 multiplied by 2 power 0, which is nothing but 1 into 1, which is 1. So the same. Conversions, friends. If you are good at conversions, you can play. So that is the reason if you have failed to attend this session, that's fine. We have it in the series. Within the same playlist, we have one of the session where we have discussed the conversions. Just go and rewatch this particular session. Right? Right. So let us work out on the next example. The next example. 10 exclusively OR operator, then 4. What will be the output? What will be the output for line number 2973? What will be the output? I want everyone to answer. So just do the conversions. The output will be 6. Will it be 6? How come 6? It will be 14. Pay attention. Do the conversions. If you take 10, 2, 5, 0, 2, 2, 1, then 2, 1, 0. So just we got the number for 10. It is 1010. Why you guys are getting confused? Then do the same for 4. We know 4, it is 100. But friends, you see towards the left side, I don't have anything. So by default, it takes 0. Now apply exclusively OR operator. So the same values, it gives the bit value as 0. But if the bit values are not same, there we'll have the output as 1. Now this binary number has to be converted to decimal number back. Let us use the formula. So this will be given as, I'm writing over here, 0 multiplied by 2 power 0 plus 1 multiplied by 2 power 1 plus 1 multiplied by 2 power 2 plus 1 multiplied by 2 power 3. So this anyways it will be 0. This will be 2. This will be 4. This will be 8. Just add up. Are you getting 6? No. The answer is 14. Why getting confused? Take your time and I want the right answers. 14 is the answer. Clear? So let me also execute that. The output for line number 2973, it is 14, not 6. Anyways, for the next line, 2974. Good. 2974. How do you represent 5? 101. 3. It is 1 1. But I don't have any value. No bit value I have towards the left side for 3. By default, it takes 0. So this will be 0. This will be 1. This will be 1. Now, what will be the output? Just do the same process. 0 multiplied by 2 power 1. 1 multiplied by 2 power, sorry, this is 0. This is 1. 1 multiplied by 2 square. So this will be 0. This will be, what will be this value? 2. This will be 4. When you add up the values, it will be 6. 6. So the output for line number 2974 should be 6. See, why am I explaining to the extreme? Is you have to be good at the conversion and getting back the output. Conversions from decimal to binary, then from binary to decimal. Conversions, very important. Time again, I am repeating the same topic. Take n number of examples. Solve n number of examples. When you solve, you will learn and you will be capable of working out on any kind of example. Any question can be answered. Clear? Yes. But the question raises, I also use the same symbol for symmetric difference. For symmetric difference. Where did we use symmetric difference? We used symmetric difference in set data type. Where did we use, guys? In set data type. So let us use symmetric difference. We'll quickly recap symmetric difference as we are using the same symbol. Okay. Now, I'm creating two set objects with the values as 10, 20, 30 in one set object, and in the other set object, the values are 20, 40 and 50. So I'm using symmetric difference function on both the set objects S1 and S2. So what will be the output for line number 2979? What values will have in S3? What values will have in line number? We'll get, sir. What values will get? Not 1030. No. That will be only difference. That's what? Basics. What is the difference between difference function and symmetric difference? Time again, I am telling you guys. No, no, no. The output will be symmetric difference function will not return the common elements. Apart from the common elements, all the uncommon elements from both the objects will be returned as part of the output. So that means 10, 30, 40, 50 enclosed in flower braces, curly braces in any order will be the output for symmetric difference. But if I use difference, the output will be 10, 30. The difference. This is difference function. This is symmetric difference function. Able to recap? Let me execute. So S1, S2, then using symmetric difference. Only the common elements will not be returned. All the uncommon elements between the objects will be returned as part of the output. This is symmetric difference. Right? Now, instead of using the symmetric difference function, I can also use the symbol. Yes. How does PVM understand? Depending on the values, the objects that we are trying to use. What kind of objects they are? Set objects. They are set objects. So PVM understands this cap symbol is nothing but symmetric difference. So the output will be the same. The output will be same again. Clear? Is it clear? Yes. Now let us get the overview of the next concept that we are going to understand. Okay, so the next concept that will be discussed is flow control statements in Python. In Python, we are going to understand flow control statements. What are these flow control statements? What are the purpose of using these flow control statements? Is, they help us to perform a certain operation. A certain operation will be performed only once. I'm underlining the keywords. Only once when the condition is either true or false. If not, or it also performs the operation repeatedly for finite number of times until the condition becomes false. Okay, so we have flow control statements in Python, and the purpose of using these flow control statements is, they help us to perform an operation when the condition is either true or false. Only it helps us to perform an operation for once. If not, or we can also perform this operation repeatedly for multiple times until the condition becomes false. Okay, so this is the purpose of using flow control statements. And in Python, we have three types of flow control statements. They are conditional or selection or branching statements. I repeat, conditional or selection or branching statements. Probably you guys may have heard about conditional statements. They are same. The other names, branching statements, selection statements. All of them are same, guys. Okay. Then the next one is looping or iterative or repetitive statements. Loops. Looping or iterative or repetitive statements. And the third one is miscellaneous flow control statements. They are break, continue, and pass. Okay, we have break, continue, and pass as miscellaneous flow control statements in Python. So from the next class, we are going to enjoy the sessions, because from here onwards, we are going to understand the important concepts of Python. Okay, so probably we'll be starting flow control statements in the next class, where initially we'll understand what are these conditional statements. What is the purpose of using a conditional statement? How many different types of conditional statements we have in Python? Okay, and understanding the syntax for each and every type, and then working on the examples. And there are multiple use cases, real-time examples we have part of these sessions. For these topics, we have added multiple use cases, and if you are going to concentrate, and especially when you learn and do practice, you can write logic for any kind of given question. For whatever might be the question, you can build your own logic. So that is our intention. For that reason, we have bought multiple use cases. Probably there are around 50 to 60 cases. Okay. For all these three, we have brought around 60 to 70 examples. Okay. Where we'll be building a marks memo. For a student, we can build a marks memo, isn't it? Yes. We'll use conditional statements and we'll bring a marks memo. We can also bring a pay slip. Once if you work in real time, you'll be given pay slips, your salary slips. Okay, so these salary slips can be built using the logic, right? We can write the logic for the pay slips, salary slips using conditional statements. So multiple wonderful stuff is waiting for us in the upcoming sessions. So don't miss out the sessions, friends. My humble request, just continue with the same flow. One day you'll excel in the world of Python. One day you'll excel in the field of Python, because from here onwards we are going to have the core important concepts. Under core Python, we are going to have the important concepts, conditional statements, loops. Then we also have flow control statements like break, continue, and pass. What is the purpose? Under loops, what are the types we have? Okay, each and everything we are going to understand. Probably you may not get the content from, outside anywhere else. We are going to provide, right? So any questions for the day? How was the session? First of all, the technical questions. Please shoot your questions. Come on, guys. Interact, whatever it might be, even if it is a non-technical question. Yes, you can also ask the non-technical questions. Thank you. Thanks for your feedback. And as a part of an encouragement, just hit on the like button. Okay. As a kind of support that you are going to give from your side to us, hit on the like button and do share these sessions to your connections. Ask them to learn Python. That's fine. You can also go through the recorded session. It is anyways available in the YouTube, right? Thank you. Thank you. So for freshers especially, in general, the questions will be from the core concepts like data types, conditional statements, loops. functions. Okay, then the packages, whatever the modules that we are aware of, from these topics we'll have the questions. That is more than enough at a fresher level. Anyways, the feedback link has been provided. Give your valuable feedback before you leave, friends, and ensure that you like to our session. To this particular video, give the hit on the like button, and do share across your connections as well.